All right, this is your objective, all right? And this is what these things look like, all right? It's an example. And this is what it is. And you really want to take that S off of there. It's the same molecule, all right? They work, but they're different, all right? And I'll explain it in terms of this. You look at this sulfur and these oxygens, and all of these, they all have 8 valence electrons, and I have the correct number of electrons in it, all right? So they're both valid, all right? Now here are some facts about it. This is how you know that they're a resonance with that thing. And this is really interesting. The true structure of these molecules is like a combination of one or the other. This uh, phenomena affects the bonds. These bonds aren't quite a single bond, or they're not quite a double bond, and it's bond order is 1.5. All right, they both are. Now, how to do it? What you need to get familiar with is when you do Lewis dot diagrams, you just need to know to look out for them and know they exist, so that you know they got to be on your radar, kind of thing. All right. Now we're going to go through 2 examples for sulfur dioxide. All right. The first thing you want to do is for Lewis dot diagrams, you want to find the total number of valence. So for sulfur dioxide, both group 16, that's 18. Central atom is going to be sulfur because it's the least electronegative. You put your atoms around it, you use the other atoms around it, and you use single bonds. You find out how many valence electrons you have left. 18 minus 4, all right, is 14. And then you're going to distribute them to get everybody until you use them up and to give everybody an octet. All right. Now 6, 14, 6, 10, and 4, that's 14. And then you check, and you'll notice that this oxygen only has 6, where everyone else has 8. We got to correct that. All right. So the sulfur is going to sulfur is going to give some electrons here, and you're going to make a double bond. All right. And there you go. You may be like, done. Now, I'm going to draw them out in a different way to show where the idea of resonance is coming. Now, if you distribute these electrons out like this, all right, you can see that the sulfur only has 6, 2, 4, 6. The oxygens are happy. However, which oxygen is going to give this lone pair to the sulfur? Where is the double bond going to be existing? It could be either. Therefore, in truth, they both actually kind of do it. They both lend about a half, and you end up with a resonance structure for this Lewis dot diagram. All right, and this is what it looks like. Right, where you have the double bond on the left of the sulfur, not on the right. And typically, these things are written linearly. All right, but I didn't have enough space. All right, let's do another example. Nitrate, NO3, one of the most soluble anions. Took me a while to find that word. Okay, I'm going to find out how many valence electrons I have. Okay, group 5, group 15, and group 16, plus the negative is going to give me 18. No, not 18. It's going to give me a total of 24. My least electronegative element is N. I'm thinking sulfur from the last example. Put the other ones around it. Single bonds, subtract the total number of electrons bonding from the total number of valence. 24 minus 6 gives me 18 left. All right. So now you distribute them. Good. Boom, bang, boom. I'm all done. Any problems? Check. All the oxygens are happy, but the nitrogen in the center only has 6. Now here is where you should be looking out for resonance, because all of these nitrogens can donate a pair. Which one's going to do it? And the truth is, they all kind of do it to a degree. They all give about a third. All right. And we're just going to have this one on the right do it. And then you'd get this Lewis dot diagram structure for this Yeah, this anion or ion. But in truth, there are three resonance structures. All right. One where we're showing the double bond between the top, one on the bottom right, and then one on the bottom left. All right. And once again, these things are typically written in a line. All right. I hope that was helpful, and let me know if I can do anything to help you. All right. Bye.